Hello, can you hear me? All right, great. So, my name is Ian, and I'll be your instructor for today. So, today the game we're going to be making would be Ice Cave. It's a game from Pokemon. If you haven't heard of it, then I'll show you later. And so the platform, which is like the way we're going to make the code that we're going to be using today, would be Microsoft Make Code Arcade, and yeah, you'll use block coding to make a video game. But through this platform, you can basically make any video game you can imagine. Yeah, so today our assistant instructors will be Justin and Murphy. And yeah, before we get into the teaching, let me show you the full game first. Right, so this is what the game is supposed to look like. So as you can see, we have to glide across the ice and hit the rocks so we can change directions and finally get to the blue tile. And you might notice that our starting point is on the gray tile on the map. Right. So I'll turn on my camera. Sure, why not? So our lesson outline, we divided the game coding into four stages. So stage one would be setup. So we are setting up the game. Stage two will be making our sprites move. And in stage three, we'll be coding more levels so we can make the game more interesting. And stage four will actually be an optional challenge level stage we won't teach, so you'll have to complete that on your own. But we've included solutions on our slides. Right, so before we get into the actual game, I want to introduce you to the components of our computer program. So, like, computer programs are everywhere and they're made out of three main components. So, the first one would be input. So, whatever the computer can detect. And then the second one will be control, which is basically like the computer making decisions. And the final one would be output, which is what you as like a person using the computer can see or hear or experience. So I've got examples here for you. So for example, you have an alarm and you can set that to ring at 9:30. So the control component of the computer would repeatedly ask whether it's 9:30 yet, and if it is 9:30, it would sound the alarm so you can wake up and not miss school, even though 9:30 is a terribly late time to go to school. Right, and another example would be entering 2 times 3 into the calculator. So after you enter that into the calculator will actually have to calculate 2 times 3 because it doesn't automatically know that it's 6. So after the calculator calculates 2 times 3, the output would be the screen displaying 6. So I think that makes sense. So assuming it does make sense, can you think of more common everyday appliances that use computer programs? You can try separating them into like the three components. For example, the close door button pressed in the lift, whether the door is obstructed, and closing the door if it's not. So anyone got any examples? Follow the format as shown on the slides. Um, Andrea, do you have Andrea? I don't know. Do you have any answers? Andrea? Right. I guess not. Emma, do you have any answers for us? If anyone else has any answers, feel free. Guess not. Alright then, we're on a bit of a time crunch, so let's move on. So this will be our user interface, and as you can see, it resembles a console, or like think of it like a Nintendo Switch. So obviously our buttons down here will be our input, and then like the control will actually be the code we put into our game. And like the output would be like the screen where we can see things happen. So next, we will teach procedural execution. So it's a complicated word, but you don't actually need to know anything about it. So all you need to know is that code runs from top to bottom and does so really fast. So let's consider the code from the previous slide, which is down here. When the A button is pressed, what do you think the color of the screen will be? Because first we set the background color to red, and then we set the background color to yellow. So when A is pressed, what would the color of the screen be? Anyone got any answers? Good job, Yanni. Yeah, the answer is yellow, because as the code runs very quickly, the red doesn't actually show. So we need to fix it, right? So to make the yellow actually show, we have to add a pause in there. So if we tell the computers to stop for 1 second while we set the background color to red, we'll see that the red actually shows, and it's just too fast for the human eye to see. So it would turn red and then wait for 1 second and then turn to yellow, as I'm about to show you here, if the thing will load. In time. Right, so if I start the game and press A, you'll see that without the pause, it only show yellow. But if I add a pause in here and make it pause for 1 second, and press A, it'll show red and then yellow. So that's pretty neat. Right, so now that we've learned the basics, we can get into our coding. So we'll start stage 1 setup, which is making the stage where the game is played. So just as an artist without a canvas can't make art, the same goes with coding. So let's start by opening our program. So our assistant here will send you a template via the Google Meets chat over here. And if you click on that, you can click Edit Code in the top of the screen. And if you do that, it'll show you all the code. And you'll notice that our template slide doesn't have any code yet, but we actually have assets or like pictures ready for you, so you don't have to draw them, since that takes up a lot of time. So now that we have this screen, you'll learn how to start a line of code. So basically, we want a block that signals an event to start when the program runs. So you can think of it like the home button on your phone. So to do that, we'll have a folder called loops. Over here are all the blocks you can find. So if you click on them, you can find a lot of different blocks. It's a bit overwhelming at first, but it'll get easy when you get used to it. So basically, we're looking for a block called onStart. So as the name suggests, when you click the start button, it'll run the code. So the blocks inside the onStart button will run as long as you start the program. Right, so if we run this program, if the code will load. Guess it won't. Right, so we need a map. So because you can't play a game without a map. So out of all of these, which folder do you think fits that category the best? Felicia Wong. Do you know what folder fits the map category the best out of all of these? or anyone else? Yeah, scene. Yeah, you got it right. Good job. Yeah, so we actually need our scene folder, and so now we just need a block that sets our map. So if we click on scene here, you'll see we have a lot of blocks. So like, like the block that is related to the map. J code. Do you know what block would we use to set our map? Guess not. All right. So basically, we'll need to use tile maps. So a tile map is basically like a background image. So like a tile map is an easy way to make a map, but like it's made out of individual squares called tiles. So if you look at your floor, you might see that there are like squares all around, and this is kind of similar, except each square has like a different image, so we can like make really pretty backgrounds. Right, so you want to drag that tile map block, you can find that over here, and drag that into our onStart block. And what that will do is set our tile map for us. But you might notice that like when you run this program, which my game is like really adamant on not running. There's still no map. So like, this is because even though you've added the tile map block, you'll see that there's actually no map over here. So like, it's like calling and entering a taxi, but the driver doesn't know where you want to go. So to fix that, we already crafted some tile maps. So if you click this gray box and go to assets, you'll find all of these tile maps ready for use. And the one we'll use is the most simple one, and it's actually called level 1, as you can see over here. So you click on it, you can see that it basically resembles our level 1. And so if you click on it and click done, and then we run the code, you can see that there's now a tile map. So that's nice. So next, we need the player. So a player would be a character called a sprite in the coding language. And so it's not actually a sprite. Well, it is actually a sprite, but it's not a can of soda. And instead, it's more like a character you put on the screen to control it. So think of it like a player. So a sprite can be any design, but we'll stick with a human for now. So just like the tile map, we'll go to the sprite section, which shows everything to do with sprites. And then we'll drag this down here. And then similarly, like before, we can click on this gray box, go to My Assets, and then we can see that there are already 4 players here. And they're actually the same player, but facing different directions. So you want to click on the one that's facing the front. And now you click done, and we run the code again. You can see that there's a player in the middle of our screen. But now we might want to like change the name of our sprite. So what we can do is click over here and then go rename variable. So what should we rename this name? This sprite. So something like glider would work perfectly as a name, but not like a German name like Wolfeschlelgenslein Hossenbergerdorf Senior, because you would probably regret looking at it time and time again. So let's name our slide glider by typing glider into the box and press OK. And as you can see from here, our sprite is now named glider, and that's pretty cool. Right, and like to end stage 1, our final issue is that our sprite is in the wrong place. So as you saw from the scene from the game before, Alex?
I want to ask, can you send the link again? Because just now I rejoined with another device and I don't have the link.
You want the What kind of link do you
Okay,
want?
the game link, thanks.
All right. Yeah. So we want our sprite to start on the gray tile and not in the middle of the ice because that makes no sense. So let's signal to the game to pick that tile. So because everything to do with tile maps you can find on the scene section, we can go over here and we'll find a very handy line of code called place my sprite on top of random tile. So we put that below. We can see that there's only one of these gray tiles here. So if we set our glider, remember this should be glider, not my sprite, since we just renamed our sprite to glider. It'll actually go to a random gray tile. And the neat thing is that like there's only one gray tile, so the sprite will always go to the gray tile every time. Yeah, so stage 1 is complete, and here is what your code should look like right now. So it'll give you 1 minute to fix your code. And if you're falling behind, you can hop into our Google Meets links for individual consultation with our wonderful assistant, Justin. Or you can go to our PowerPoints and check back on the code you might have missed because I went too fast. And alternatively, you can also use our checkpoint here, which will basically give you this code, so if you're too far behind, you can instantly catch up. So I'll wait for a bit more so we can... Yep, that should be 1 minute. So remember, if you're falling behind, you can go into a Google Meets links for individual consultation. You can check our PowerPoints, and our assistant will now send the link for the stage 1 checkpoint. If you're caught up with the code, you don't need to use it, but if you're not, it'd be nice to use it so you aren't too far behind. Right, so stage 2 is movement, and basically we have to make your sprite move around. And this stage will be more difficult than the last stage, so good luck. First, it's always good to go over our objectives so we know what we actually need to do. So our objectives would be wanting our sprite to glide in the direction of our choice, and our sprite should not stop until it hits a boulder. And once it hits a boulder, our sprite should stop. That's pretty cool. So the first thing would be wanting our sprite to glide in the direction of our choice. So to do that, we can use something called coordinates. So if you played Roblox or Minecraft or any other video game before, you'll know that a cool way to do that would be using WASD keys. But on this console, we'll actually use this keypad over here that goes up, down, left, and right. And yeah. So to do that, we'll use functions. So basically, a function allows you to run a sequence of code every time you call the function using this call function block. So when you run the call function block, the code inside of the function runs, and this makes our code shorter so that less mistakes would be made. So to do that, we'll have to define our function. So if you click into Advanced and go to Functions, you can make a function, and we'll call this function glide. And so everything we put inside this function will happen when we call the function using this block, call glide. But this function is incomplete, so let's edit this function. We can add 2 numbers here, and we can call that phi x and phi y. So this may sound like it stands for nothing, but phi x stands for velocity x, and phi y stands for velocity y, and velocity is another word for speed. So if you look at the compass here, you'll realize that y is going up and down, and x is going left and right. So if we add this minus sign in front of the y, it'll go up. And if we add the minus sign in front of the x, it'll go left. And otherwise, if you don't, the y will make it go down, and a positive y, which is when you don't have a minus sign, will make it go left for the right for the x. So yeah, so you'll add 2 numbers and name them vx and vy. So now we'll have to set our sprite to move when we glide, obviously. So we'll use this block of code called set my sprite velocity. Remember that velocity means speed to phyx and vy. So we can drag phyx and vy here. I'll explain why later. And as always, you have to set this to glider. Right. So now that we've defined our function, we can go to controller. And here is a statement that basically means when the left button is pressed, or when you drag it to your keypad to the left, something will happen. So the something you want to happen would be you call the function glide. And so since it's to the left, if you check the compass here, you realize that it's negative x. So we'll do negative 75 because, as you can see here, the left is x, and we'll do 0 for y. Since when the left button is pressed, you don't want it to go up and down. Right, so let's try this code. And as you can see, the sprite goes to the left when you press the left button. But you might notice that it's still facing the front, so we want to change that. And to do that, we'll go to sprites. And then at the very bottom, there's a block of code called set my sprite image to. So we drag that over here. We can go set glider image to the left. So if we run the code again, it'll go to the left, like that. But also, you might notice that our sprite phases through the rock, and from common sense, you know that people can't go through rocks normally, which is a shame. So we should probably fix this. And to do that, we'll have to go back to the tile map over here, since that's where the rocks are.
But I
And we'll yeah. So you can draw walls. So if you drag your mouse button while clicking this draw wall function section over here, you'll realize that everything you draw will be like tinted red, and that's good since it means there's a wall there. So now, after you've drawn your walls using the draw wall function, we can test our code again, and we might be able to see that our sprite hits the rock, which is good. So now, you might realize that wait, what? Yeah. Wait, yeah, so now we want to like replicate this for other arrow keys, right? So you can't move left, right. You can only move left, you can't move right, you can't move up, you can't move down. So let's change this function to the text of you're pressing the button down. And so if you refer to the compass, you'll realize that down would be Y and without the minus sign in front. So we can just do 75. And if we run the code, we can now move down, which is good. And similarly, we want to change our sprite's direction to face the front, or well, down in this case. Right. And now, if you test the code, once again, testing is very important. You'll realize that you can actually change directions while you're gliding. And you don't really want that, since that kind of breaks the point of the game. And so we need a way to detect whether the sprite is gliding or not. And the way we'll do that is through something called variables. And that sounds like a very complicated term. So variable is simply a value that can be changed and stored. And this is very important, so try to remember that. So for example, the digits of your clock is a variable because you can change and store your variable. And the number of hearts on your health bar is also a variable. So in this case, we need a variable that tells us whether or not our sprite is gliding. And before that, let's go over variables a bit more because it's a rather complicated concept. So as you can see here, you have 8 hearts. So the number of hearts you have would be 8. And over here you have, wait, no, you have 10 hearts. 10, sorry. Yeah, and your experience bar is 1. So the variable for that would be 1. And then even the inventory slots would be variables, even though they're more complicated ones that show like what item is in like each slot in your hotbar. So that's a good analogy to think of if you play Minecraft. Great. So if we know we need to use variables to tell us whether or not our sprite is gliding, we can create our own variable using the variable tab, and these are so important that like MakeCode has a separate folder for them. So if you click make a variable, you make a variable, and we'll call our variable glide, since we're basically asking whether our sprite is gliding or not. So remember, click on make a variable and go on glide. Right, so when our sprite is gliding, we want our glide variable to be 1, and that's a completely arbitrary or random number. You can use any number you want, but we'll use 1. So we can move that into our function here. So we'll set glide to 1 when you call glide. And so basically this will mean whenever you're gliding, you'll be 1. The glide variable will be 1. But, and this part is a bit harder, when our sprite is like not moving, we want glide to be 0. So over here, yeah, you want to set our glide to 0. And another thing we want to do that I forgot before is change our image back to looking at the front when we hit a rock. So as you can see, our thing is still looking at the rock, and why would you stare at a rock, right? So you should just change the image to work normally. We drag that into our sprite of kind player hits wall. So this is just the text whether you're hitting a wall. And we'll set our thing to look at the front. So I'll go over this again because I feel like I might have skimmed past it. So when our sprite or our player hits the wall, you'll set our glider to look at the front, as you can see here. And we'll also set our glide variable to 0. So the game knows that we're not gliding anymore. As you can see, we've stopped. So now we want to make it so that when we are gliding, we can't change directions. So the game is more fun and interesting. So the way we'll do that will be using if statements. So like an if statement sounds complicated, but you use it everywhere in your everyday life. So like some examples of if statements is, for example, if the time is after 8 o'clock, you go to your classroom. Or if the teacher is not in the room, you can cause chaos. Or if you're missing homework, then you can lie about owning a dog. So we need an if statement that checks whether or not our sprite is already moving. And if it is, do nothing. But if it's not, you'll be able to glide down or left. So in our logic section here, we can use if true over here. And then we can go over here and click and drag this over here, which is if 0 equals 0. We can then drag our glide variable over here and detect whether we're gliding. And if we're not gliding, we want to be able to change directions. So if glide equals 0, then we should be able to change directions. So I hope this makes sense. So if you're not gliding, you'll be able to change directions. And I'll duplicate this over here. And now let's test out our code, since we shouldn't be able to change directions anymore mid-gliding. And as you can see, we cannot. And that's good.
Can
So,
you go back to the code you made to little bit?
this slide? Oh, this slide.
Yeah, thank you.
Okay, sure. You can also go to our individual consultation links or look at our PowerPoints if I'm going too fast, since we are probably on a time crunch. I think we can spare some time though, since we have quite a bit of time left. Are you okay now, Keiko?
Yep.
All right, great. So now we have to replicate this for moving up and right. So you'll have to refer. So first, I'll teach you how to duplicate your code. So you right-click on your existing code. Remember to right-click the brown part to copy everything inside of it. And when you click the word duplicate, it copies your code, which is very handy. And obviously, we want it to move up and right. So first, we'll set it to detect whether we're going right. And so now we need to decide what to put inside our call glide function. So when we're moving right, what do we want? Negative x or x? Carson, want to answer? Should we, when we're moving right, should we go in the x direction or the negative x direction? When we're moving right, remember? So right would be this way. Yeah, so it would be positive. Since negative is when there's a minus sign in front of the x. But good job for trying anyway. Right, so since we're going to have to do this positive x, then x is on the left. So we have to put 75 into our call glide function. Right, and what's about moving up? Nathan, do you want to answer? Will we move in the negative y direction or the positive y direction? When we're moving up. Remember to refer to the compass. Tom, do you have any suggestions? Guess not. So we'll actually move in the negative y direction, as we can see on the compass. So negative y would be up. So over here, when we're pressing the up button, we want to go negative 75. So yeah, let's check our code now, I guess. Left works, right also works, left works again, up works, and finally down also works. So that's great. Okay, now we've got that done. For the game to function properly at the start, we should reset all our variables, including our velocity, which means speed. So at the start, we'll set our glider's velocity to 0, 0. So basically it doesn't move since the speed is 0. And we'll also set our glide variable to 0 so that the game knows that we're not gliding. And so this is what your final code should look like. And so now you have 5 minutes to catch up on the code. And if you forgot the steps, you can refer back to our PowerPoints or ask our teaching assistant in the breakout meets. Or you can use our stage 2 checkpoint slide, which has all the code we did beforehand, so you can catch up instantly. Right, so I'll wait for a few more minutes so you can catch up. Yeah, mind if you also send the slides and the meetout breakout rooms as well, please? All right, I'll wait for 1 more minute to 2. All right, so 1 minute has passed, so let's get on with stage 3, which would be creating more levels to play in. So yeah, click the checkpoint if you're still behind, or check our PowerPoint. So it isn't a cave without an exit. So basically, we need a win condition or an exit the sprite has to reach to progress in the game. So to progress in Ice Cave, the sprite has to get to this blue tile over here. It's also over here. So we want to see if our sprite is touching the blue tile, and if it is, the player can move on to the next level. So we need to code this into our game. So we can actually have this super handy block of code here to check if it touches. So on sprite of kind player overlaps tile at location. So as always, anything tile related is in the scene folder. So we can drag that over here. So when a sprite of kind player overlaps our blue tile at location, something will happen. So before we can set the level, we actually need to remember what level it currently is. So is there anything we've learned that would let us store what our current level is? A value that can be changed and stored. Anyone remembers the name of the thing we learned? Yanni? Yeah, variables. Good job, Emma. So we're going to have to use variables again because they're super handy. So for a recap, variables are values that can change and have many uses, such as storing data. So in the variables folder here, we'll make a new variable and we'll call it level. And so this will allow us to alter what the code does depending on what level the player is currently on. So we want the level to be 1 when the game starts because that's the starting level. So when the game starts, we'll set the level to 1. But then when the player touches the blue tile, the level should also change by 1. So we have to drag a change level block into our whether it's overlapping. And the difference between set and change is that set sets it instantly, while change is more like addition and subtraction. So if the current value for level is 5, if you change it by 1, it'll become 6. But if you set it to 1, it'll become 1. I hope that makes sense. Right, so now that it can change the level when you overlap with the blue tile, and you set the level to 1 in the beginning, we can actually do things with it. So we need a way to change our tile map because our tile map is the level, right? Depending on the level the player should be on. So can anyone recall a block of code that tells the game to do certain things, but only if certain conditions are met? Rocco. Yeah, good job. It's if true. But we'll actually use something called if-else blocks. So basically, if the conditions are met, it'll run a certain line of code. But if they're not, it'll also run some form of code. And so as a recap, if statements are decision-making statements that tell the computer what to do in certain situations. So that's a handy definition to have if you ever forget. So you'll drag an if-else statement into our if it overlaps over here. So first we want to so basically we want to detect what level it is. So first we'll have the if part. So if the level, I'm going to drag all of these into here, equals to 1, then the tile map should change to level 1. So basically, we'll go back to scene, and then go to tile map. And so if the level is 1, the tile map should be level 1, which is the one here. So you can change the tile map. And that's great. But now we also need the else part. So what would we put in the else part? What line of code would we run? So this is a rhetorical question. So the line of code we'd run is duplicating the if-else statement and chaining it back here. So we'll call this an if-else chain. So now, if the level equals to 2, we want it to switch to level 2. So if the level equals to 2, we can go over here to level 2. And before we test the code, we also want to draw walls. And remember the rocks are walls too, as the player is supposed to collide with them. And obviously the outer ring is also walls. But remember not to set your gray or blue tile to a wall, because the player actually has to touch those. Right, so you can draw walls using the draw wall function if you've forgotten. And yeah, now we can test our code. So if you go over here, oh right. Let's just copy this over first, actually. So basically, we want to copy these free blocks. So the place glider on top of random thing. So as you can see from our failed code, the glider is still in the position of the original tile. So we want it to go back to the gray tile over here. You'll also set the velocity to 0, so the glider doesn't move. And finally, we'll set glide to 0 because we're not gliding anymore. So we'll put that at the bottom of our whether it overlaps block. So all of these will run when we touch the blue tile. So now let's test the code. As you can see, we're now onto the second level, and we can play that second level. Oh, I'll have to change the image here, which is super important, but I've forgotten. So remember to make it face the right direction, because if not, it looks weird, as you've seen just now. Oh, let's test that again. Great. And now we need to let the game know that we won, because winning is good. So after the second level, but you can add more levels later, you'll use this block called Game Over, which tells the game it's game over. But we want it to be a good game over, so if you click on the lose button here, you'll flip a switch and it'll turn to win. So basically, when the game is over, you'll win. And if we try the game again, you'll see that there's a fancy pop-up. And that's great. And we've already added this final touch. So as a recap, we detected whether the sprite was on the blue tile, and if it was, we used a variable to keep track of the level by changing it by 1. And finally, we used if-else blocks to set the tile map depending on the value of the variable level. And so now you'll have 5 minutes to catch up on the code. If you forgot the steps, remember to refer back to our PowerPoint or ask our teaching assistant in the breakout meetings. Yeah, and that's stage 3 done. And we actually still have 13 minutes. So after I grab a glass of water, I'll actually go teach you some of the optional levels so the game can feel more polished. You'll have 5 minutes to finish your code. And remember, if you have any questions, you can ask. And if you don't want to ask, you can go to our PowerPoint. And yeah, here's the code for stage 3, Emma. Right, so at 11:20, we'll continue and teach some of the optional stages. Right, and before I forget, we actually have an evaluation form, so you can tell me what to improve. So maybe I didn't do a good job of explaining, or maybe I went too fast, or maybe the code was just too complicated. We'd like to hear your feedback, so maybe our assistant can send the evaluation form over. Yeah, so if you have time, please fill in this evaluation form. It helps us a lot because yeah, I sound like a desperate YouTuber. Right, and you're actually free to contact us by email. We're at CKY HOC stands for Hour of Code, at gmail.com. And you can also visit our website. If you forget these, you can look at our PowerPoint, I remember. Right, so it's 11:20 now, so let's get on to the challenge levels. I'll go through them first and then teach them one by one. So first up, we have cleaning up the mess. So like, as you can see, our current code is very messy. There are if statements all over the place. So could we fix this using the Functions tab in MakeCode Arcade? And so if we go to the Functions tab, I'll actually not go through these. Should I go through these? Raise your hand if you want me to go through the challenge levels. Alright, sure, I'll go through them then. Great, so we'll make a function, and we'll call this function reset. Because basically what we want is to have a function to reset everything. And we'll actually put these lines of code. So everything there below the change level by 1. And we'll drag that into our new function. And we also want some pieces over here, I think. Actually, no, we don't. Never mind. Oh, yeah, we also want to set our glider image to the front because that looks better. And so after you've defined this super handy function, you can call it everywhere you need it. So we have a call reset block. So we delete this, we input our call reset block over here. It shouldn't affect anything. And we can also put our call reset block over here. And so, yeah, if you test out the code, it works as normal, except now it looks really tidy. Not that much tidier, but you get the gist. Right, and the second one would be sound of success. So basically, the game is quite quiet and lacks sound, so why don't we fix that? So using the Music tab in MakeCode Arcade, we can add a cool sound effect when the sprite reaches the blue tile to congratulate the player. So over here, when it touches the blue tile, we can play the sound ba-ding. So let's see what that sounds like. It's in the Music tab, by the way, and in the first one, play sound. When we touch the blue tile, there's a ba-ding, and I don't know if you can hear that, but you should be able to hear that if you try it out yourself. And more levels kind of takes time and isn't that hard, so I'll skip it for now. This one is pretty important, so actually, I should do the more levels. Wait, should I? Yeah, I should. Alright, so let's make more levels. All you have to do, really, is chain all of these again. So more if-else statement chaining to make it cooler. So we have 4 levels in total we made for you. So we can set this, if level is free, we can set the level to level free. You have to remember to draw the walls, as always, because the sprite is supposed to collide with them. Oops. And if it's level 4, it should go to level 4. So, shouldn't be too hard, but if you're confused, you can ask. So we have level 1, level 2, level 3, and level 4. And we win. Great. So our final challenge would be reset the level. So basically, if we play this game again, you'll find out that we can actually get stuck, and there will be no way for us to win, and we don't want that happening. For example, here, is there a way for us to win? No, there's not. So we're stuck, and the only way for us to reset would be to start all over again. And that's pretty inconvenient. So what we want to do is, so when the player presses A, all we got to do is call our function reset. This is super handy. You see why now. So when you press A while being stuck, you get to reset the level and play it all over again without having to do all of the easy levels. Yeah, like that. Right, and so that should be everything. Yuet, do you have any questions?
Will have a link to the whole finished product of this code?
You can find that on our PowerPoint, but I can send that over right now. Should be somewhere. Someone sent it already? No, I'll send it. Here's the link to the finished product if you just want to play it, or you want to compare your code to it to make sure you didn't miss anything. Anyone else have more questions? We have 3 minutes left. You can just ask, you don't have to like, yeah. If not, then if you have time, Asian form, I think I spelled that right. Please fill out our evaluation form because it's helpful. And yeah. Also, if you want to, you can actually create your own levels. So you can get creative and make your own puzzles to challenge your family or friends, I guess. And yeah, and to do that, all you need to do is load our project, as always. Click on this, and if you click on my tiles, you have rocks, so you can draw the rocks or whatever, and like make more levels that might be more fun, more challenging, or easier if you're that type of guy. So we're done now. So I think if there's not anything else, if you want to, you can leave. But I'll stay here until most of you leave.
Okay, then I'll go. Bye bye.